We had like 25,000 offers. Last year when we started, we prepared to launch the marketplace. We were almost at 100,000, roughly. Right now we are hovering about 1 million, and the problem is how to get to the next step, which is 10 million. Okay. On the technical side, the challenge that we suffer is basically that Sonai as a whole is a company with a large history in terms of IT. It started more than 25 years ago, and we still use some of the systems from that era. That's a fact of life. We cannot work around it, and we are trying, everybody's trying to get over it. The growth has been organically in a lot of ways. There are some planning, some initiatives, but mostly was focused on the offline, on the retail side of the business until about 6 years ago when we started moving online. And we are still catching up with that changes, with those changes in terms of the systems. It's still a lot of, what do you call the classic definition of legacy? I mean, old systems that are not real-time friendly. Real-time is like a third-class citizen. It's not done for real-time. And there are some systems that we need to use are not 24/7, for example. They have official downtime periods, which causes some problems that we have to deal with on the e-commerce side, where it is a 24/7 business. Okay? The architecture that we choose for the digital area is very simple. We try to have all the data integration at the start of the pipeline to clean up as much as possible of the outside world. In the beginning, with mostly ERP systems, with Marketplace, we are also trying to clean up data that we receive from the sellers that are present on the Marketplace. And as we grow, we are starting to integrate directly with suppliers, and it's our concern that the data that you get from them is not that good most of the time. It goes into a big business logic hub where we make sure that all the extra stuff that the e-commerce site needs is added on, like campaigns, targeting, pictures, images, media, everything is added on. It's piled on. And then it flows into, let's say, a site operations phase, where the most important feature, the most important metric is how fast can we render a page and send it out to the customers. There is a strong correlation between response time and conversion rate in e-commerce. So that's one of our main concerns here. We try to make everything as possible, as fast as possible at this layer. And then the final step is the after-sales operations, everything regarding to orders, fulfillment, and tracking of those orders until they reach the customer. So this basically is arranged as a pipeline. And the idea of the pipeline is to separate a lot of control plane and data plane. So our business logic is actually the control plane, and the site operations and the after sales is our data plane. That we can, everything is decided at the beginning and the business logic, and then flows into the other areas. It also allows us that if for some reason we have to have a maintenance on the business logic, the site operations is 90% isolated, so it can keep working and can keep doing all the major tasks without affecting the business logic. And for the same reason, if there is a problem on the after-sales components, the site can still keep on selling, and when the other part goes back, we move on. So there are clear interfaces between all of these areas, and it's very easy for us to operate that way. Now, given that we want to have a real-time system as possible, and we are using, we have to depend on a lot of legacy systems still, we try to convert all the messaging that we get from legacy, which is mostly batch, into real-time feeds. We use a lot of technologies over time. We started with NSQ, and we are experimenting a lot with Kinesis and Kafka soon, so that we can move from the NSQ model to the stream-based model, which is easier to recover and easy to guarantee sequencing, for example. Our size is about 100 plus topics, flowing every day. We have about 400 active consumers, and we exchange about 15 million messages per day at that layer. In the business logic, there is a large section of pre-calculation to make the next part, the site, as fast as possible. So we try to pre-calculate and store in memory as much as we can. So all the business logic, all the rules that the business defines, we try to pre-calculate them and apply them to a memory grid, and then the site can just fetch it from memory and render it as fast as it can and push it out. To do that, the implementation behind the conversion of these pre-calculations, all the conversions between business rules and the memory grid, was done with a stream processing platform that we built from scratch using Redis. We built it over the last 4 or 5 years, and it's like applying, like all the stream processings right now have, SQL concepts to streams of events. I'm going to explain a bit what we did there, because I think that's one of the biggest benefits for us. On the platform that we built, we start from an initial requirement from business. Most of what you see on the Worten site can be represented as a query like this. You select some stuff from the products database, you have some conditions. Some of them, like A and B and C equals D, are very easy in the sense that are product attributes, but then you get to user segment equals W, for example. Okay? What we do with this type of queries is that we flip them around. So instead of syncing them as that, we sync them as from products, apply some conditions, and then select the stuff. Because this way, the first initial part, what we can do is pre-calculate and leave as little as possible to calculate live. So what we do basically is that we split it. We pre-calculate the conditions individually, A equals B, C equals D. We merge them, we pre-calculate these live, and then on the site, we do the final calculation between what we were able to pre-calculate statically and the part that we cannot determine until the user visits the site. So conditions that are mostly user-based, segmentation, user segmentation, and other campaigns that the user has active, are left to the real-time portion of the site. So to keep this up to date, we basically converted all the events that we get from legacy, from marketplace, from other retailers that are connected directly to us, and we separate all the simple conditions, and we keep them up to date. So whenever a product changes, if the attribute A was updated, we check that the rule A equals B is still valid. If it is, the product has to be part of that set. If not, it has to be removed. We keep doing this on all the events, all the 15 million events per day. We then cascade these events into the uniform on the unified condition. This is done on adaptive model, which is to say, if there is very little events, we update faster. If we have a lot of load on the first layer, we try to update slower to have less impact on the front-end sites, to have less updates in real time on the site. It fluctuates between 5 and 30 seconds. We don't go above 30 seconds to keep the site as fresh as possible. Okay? But it still makes a lot of difference at the level of volumes of events that we are seeing. And we can cascade into more complex queries. For example, if there is a certain query that reuses some of the rules, we reuse those and merge them at the end. So this is like set theory meets graph theory, in that we find the path to get from one point to the other and just recalculate what you need based on what changed on the event at the beginning. This is done 15 million times a day, and more if they want to create a rule from scratch, where we have to apply all the products that we have. We have to like flush them and reapply this on top of the rules that we have. We have about 50,000 rules active at any given point in time like this, and they are calculated in 200 milliseconds on average for each set of 1,000 events. So there is room to grow. The thing is that the growth of events is something that we cannot control very well. And the biggest problem is that where do you use this? On the left-hand side of the site, when you have the filters, all of those options is a query like that. So on a standard page where we have a range of products and a lot of filters, the site usually does about 200 to 400 queries in real time to render this page. It's about 300 to 400 to calculate every single thing that you are seeing here. If you look at the filters, all those numbers, they are calculated live. If you apply a facet, a filter, all the numbers recalculate. Everything is done in 50 milliseconds in the server side. So and we do about 300 of those per page. We also use this with real-time targeting. This is a block of promotions in the site. We have, I don't know how many of those, too many to count. And each of these spaces is actually an auction based on multiple offers that are based on those lists. So each of those usually calculates about 50 to 60 to 100 queries just to render this block, where we pick the best promotion to put there to show you. We still don't do a lot of user targeting based on your behavior, but the question is that we do a lot of selling of based on the category that we are seeing. So what's hard about this is, of course, joins. When you have two streams that you join together. We are actually dumb luck. When we started, we didn't actually place close attention to a lot of products in the market. And we actually stumbled upon the joins and we solved them before we knew that we actually had a problem. So we had the fortune of creating a system for joins that actually is still sustainable and we can still keep in using it. We basically add extra nodes in the stream processing that pre-calculate all the joins that we have before applying all the rules. So the event that gets to the other phase is already a joined event with a lot of stuff. This is possible in our case because the windows of joining, in stream processing, usually when you do a join, you have to worry about the time window in which the join is going to be valid. And in our case, the time windows are very small. So pre-calculating those joins is a possibility. Okay? The other problem is, of course, growth. I mean, if you have to calculate products and those lists across all the products, when you get to these types of things, the amount of sets in Redis and the size of the sets in Redis starts to be a concern. So in some situations, for example, if they create a rule, I want all the products with price below 400, it's a lot of products. And when you have to do the intersections and the unions and all the other operations on those sets, doing an intersection with the 400,000 product set, it's with another product set with the same value, can be expensive. But given that it's an offline operation, we don't do most of this in real time, it's feasible. Okay? And this Redis-based stream basically has a problem with the growth. That's where we are working now, how to deal with 10 million. The most basic solution is sharding, and that's where we are working at the moment. The thing about that 10 million, and that we also use Redis for this, is URL resolving. If you think about it, if you have 10 million products, you have 10 million URLs to resolve, at least. The thing is that for SEO purposes, and based on our categories, each product can be in multiple categories. And the layout of the page changes based on the category that you choose to visit that product. And all of it is dynamic and calculated in Redis. So in reality, we are managing a database right now of about 45 million URLs, possible URLs. And how to represent that in memory was one of the challenges that we have. Okay? It's basically a divide and conquer. We use a lot of Lua scripts inside Redis to do all the calculations so that the performance is acceptable, and we are doing URL resolving in about 5 milliseconds. So how do you support this level of 300 queries per page views and all of those pre-calculations? We use AWS for all of this. We have about 30 instances. It fluctuates a bit with a bit of auto-scaling, but all of them are 32 gigabytes and above. We have about 20 clusters, Redis clusters, between 3 and 5 replicas for this. And we manage about 150 gigabytes of data in memory. With replication, it uses about a bit over 500 gigabytes of memory at any given point in time. So half a terabyte of memory to keep all the data that you see that powers the site. And with all those queries, we are seeing about 20 billion operations of Redis per day. So that gives more or less 234,000 operations per second. We do this, of course, across 20 clusters, 30 instances, but we do this with 2 DevOps persons. So we only have 2 DevOps to manage all of this and everything else. So the system is very much optimized to be managed by very little people according to the size that we have. In terms of technical challenges, growing the Redis-based stream processing is one of the challenges. Those events are growing exponentially. For example, on a usual day, we have 2.5, 2.6, 3 million price changes on a single day. So especially from marketplace. We have a lot of sellers, professional sellers, that compare the entire sales that they do across multiple marketplaces and keep changing the price all the time. But the technical side, although there are challenges there to solve to grow to 10 million and then to 100 million, it's not the biggest issue that we have. Managing the team is the biggest issue that we have. How to have a team that can, looking ahead, can deal with the legacy, so they can understand that legacy is a slow process to change, that we have to understand why the decisions were made, because usually there were good reasons at the time to make those decisions, how to slowly evolve them, how to slowly change parts of the legacy to be able to be more real-time, be more accurate in terms of stocks, for example. All of those things requires people that are willing to look at all the software around us with some flexibility. Becoming real-time has a lot of issues in the sense that not all your partners are able to do that. And how to deal with explosive growth. We are building our own platform for the site, and sometimes we get 100, 200,000 new products in a single day. That's normal, okay? And sometimes system breaks. We are not expecting that, and we have to deal with that constantly. There are three main things that I can show you in terms of what it means, explosive growth. For example, from the supplier side, we are more and more integrating directly with the suppliers and getting the information from them about stock prices, information about the product that they sell, and all the lead time, for example, of a delivery. And those suppliers are sending us their full range, not the product that we are selling, but all the product that they manufacture. And there has been a growth of information from there. Marketplace is still the major source of range items that we can sell, but from the more traditional supplier side, there is also being a growth as they adjust themselves to being able to talk to us in real time. That's one of the challenges that we have today from that side. From, for example, on the stores, we want to be able to not have a centralized point of sale systems. We want to have more flexibility in terms of payments. And how do you deal with people that don't have electronic means of payments? How do you deal with new payment methods that people are expecting to have? All of this requires changes. We want to have an omni-channel experience. So you want to sell everything that you see on the site we can also sell on the store, and you can choose to pick it up at home or pick it up on another store. So methods of payments is one of the big issues for us in terms of how to change, how to upgrade the stores to be able to deal it. And finally, on the supply chain and logistics side, there are a lot of options right now for having faster delivery times to your business or to your home. And how do we manage those decisions? They have a direct impact on the checkout process in the sense that during checkout, you have to do an auction and say, hey, who is available to send this product to this place in less than 2 hours? And this requires like a reverse auction, in that we have to talk with, for example, Glovo and Uber Eats to be able to get the slots that they have available for a specific time frame, for a specific source and destination. Everything like this is a lot harder when we still have stocks on a system that was not designed for this kind of decisions. So this is one of the points that it's causing us a lot of pain, and that's a problem that we have to solve in the tech team. Those three items are some of the challenges that we see in terms of growth and complexity. The thing is that how can we, on the tech team, on the digital teams, on the development teams that we have, create a culture that is capable of reacting fast, of changing fast, of being more agile, of not being afraid to move faster. Okay? Take risks and accept the consequences. Use a more scientific approach, if you want to. We are working on basically three big items, and the basis of all of this is the difference between developers and engineers. We talk about a lot about developers. I've been developing for 35 years now, and developers have a lot of fun. We write code, we like to write code, we like to see our code in production working and solving problems. But Worten is a very big company. We have a lot of responsibilities, and writing code just for writing code for the fun of it is not good enough. We have to become engineers. We have to stop being developers and act more like engineers. And what's some of the difference between those two? One of the differences is like an engineer is a much more scientific method of system design. You are not writing code to solve a problem and moving on. You have to think about the entire responsibility of a system inside your organization. You have to think about how to have a scientific method. You basically on metrics. So you design a system, you measure it, and you improve it, and you measure it and you improve it constantly. You have to have an agile deployment method and to do this, to go continuously to production. And you have to measure everything. And logs, for example. When you have a system that is running on multiple servers, you cannot just log into a server and look at what's going on. You have to collect logs, you have to centralize the logs, have a search interface for it, and you have to train your developers what is a good log. A lot of people just sprinkle logs all over the code and, okay, this is fun. But logs have a purpose. They are there so that when something goes wrong, you can quickly determine what went wrong. That's it. And that's more an art than a science. It takes some experience to determine what is a good log, because logs are a cost. You have a cost in storage, you have a cost in transfer, you have a cost in processing to index them. So you can just not put logs everywhere. You have to be careful with that. So metrics, logs, and iteration are one of the key ingredients, and something that an engineer understands that his job is not done by the time that he commits and the code passes the tests and is deployed. No, it's just starting. They have to follow up with the metrics. They have to follow up if there was a regression on the main metrics that you are following. And if something is not correct, then your metrics are not sufficient. You have to add more metrics, repeat until you get it right. So being more iteration-based is one of the key elements that separates an engineer from a developer. The other thing is understanding that the world is not black and white. There is no such this is correct, this is wrong. It always depends on the context. It always depends on the conditions. For the longest time, a lot of people assumed, and it was true for a long time, for example, that some things you don't implement on a relational database, a SQL database, queues, for example. Right now, it is debatable. There are a lot of good reasons not to put queues on a SQL database. But with the evolution of the hardware, with SSDs, with NVMEs, the I/O patterns and the I/O capabilities of the servers have changed dramatically. And actually doing queues, it's possible in SQL. One of the largest examples is SQS from AWS, which is a hyperscale queuing system that is completely based on MySQL. I assume that it's a very fine-tuned MySQL, but still, it is MySQL. So what was once wrong or not correct can be correct now And an engineer has to look at the situation, look at the data, and make a decision, and not assume a dogma that was past dogmas. The third is looking at the whole picture, getting rid of the O-fun, the optimization for fun of developers. We do like to write a lot of code. We do have a bias to build everything from scratch. And that's very true and very probably the best solution in a lot of cases. But if you don't look at the big picture, I mean, can we support this platform when you go live? That's the main big issue for me. I mean, I don't want as an engineer to be waking up at 3 in the morning because we have problems in production. So I have to make sure that the support teams, be it in my team or in other teams, are able to support this throughout the day, 24/7. So designing systems to be supportable or capable of being supported is my number one priority most of the time nowadays. It's like when you age, you get smarter. The second drive is business fit. Business fit cannot be more important than supporting a platform. I don't care how many people from the business side are yelling at me that you have to do this if I cannot support it in production. You are basically digging your own grave, you accept that. So business fit is second to support, but is important, and is the second most important thing that you have to understand. And here, a good engineer questions everything that comes from business. Why are you doing that way? Why are you taking that decision? Oh, you want to do it this way because you always did it that way. Fine, but things have moved on. Why don't we change it to do this way because it's faster, it's easier, and we can actually support this, okay? Or develop it in less time. So always question whatever comes from the business side, because most of the time they are not capable of deciding in technology terms what is a good solution. It's not their job. Their job is to figure out what they want to do with the business side. Hopefully they will be correct most of the time. And your job is to make sure that you can support that. The last important factor is sustainability, which means a lot of things. It has to be scalable. I mean, if your business grows, you have to be able to sustain it and scale up. You have to do it in a way that it doesn't cost this world and the next. If you cannot afford to scale up a solution, it's not a good fit, it's not sustainable. So sustainability has a lot of dimensions. And the third dimension is the team. If you cannot hire the people to sustain the platform that you are choosing, it's not a good fit. It doesn't matter how many quadrants it fits in the Gartner, okay? It's just not sustainable, okay? The question for Worten is, how do we get there? How do we get to building a team of engineers that can help us grow to 10 million, 100 million, and more than that? And how do we hire engineers? Over the past year, the last year, we have been doing a lot of experiments. I don't claim that I have all the answers, but I have a lot of experience doing this. And there are things that work and things that make sense and things that don't make sense. In terms of methodology, Agile makes sense. Focusing on Kanban, Scrum, whatever is the latest thing of the day, doesn't make sense. It's not about the names that you give things, it's to taking the best of all of those and applying them to your use case. It's about fit. In a lot of ways, at the moment we have teams that are working on Scrum because it fits the product, it fits the way that the product is developed, and then other systems that use Kanban because it fits the team, it fits the product that we're working on. So there is no one size fits all. And you have to be strong enough, you have to be confident enough to say, no, I'm not going to use all the ceremonies that Scrum has. A lot of them are very, very good. A lot of them are not. Some teams like it, some teams don't. I do not recommend that you start with a clean slate. No, if you are just starting, pick one and follow it. But when you start getting into problems, when you start looking at it doesn't fit exactly the way that you want to work, then it's time to adjust and do it without fear. It's your company, it's your productivity. It's not the productivity of the guy that wrote the book. So you have to adjust to your needs. One thing that we are trying to experiment more, and I think that's one of the important things that I wanted to point out, is the interview process. The classic interview process usually rotates around code reviews or do a small FizzBuzz experiment and show me your code, or solve this problem on a whiteboard or something like that. I've been doing some mind control experiments with some of our candidates in which I don't ask them nothing, not of that. From my point of view, I don't care how good they code. Basically, if they don't code well, I will understand that the first month. I cannot understand if they are going to code well in the 1 hour or 6 one-hour interviews. But after 1 month, I will know that. So I'm not focusing on the quality of their code. Usually, if they get to the point where they are doing an interview with you, they know, I already showed them part of our stack, and they know it's not like a small thing. And so if they don't know how to code, we can see that. Okay? What I'm interested on is the engineering part of the person. How do they communicate? How do they think about the problem? How do they solve the problem? But most specifically, how do they write about the solution to the problem? When you force people to put their designs, their solutions on paper, you just tell them, look, this is the problem that you have to solve. Go home, come back in a week, and bring me a 1-sheet A4 paper with the solution. Write it down. When they are forced to write it down, they have to find the correct structure to expose the problem. They have to find the correct structure and sequence to explain to me the solution. They have to find the proper diagrams to point out the relevant parts of the architecture. And that's what you are looking for on your engineers, the capability of communicate the solution that they come up with to the other guys, the persons that work with them, that will help him develop the solution, and the guys that come after. The guys that will be here the next year when this guy has left to another opportunity. So by forcing people to write down those ideas in an interview process offline and send it to me, we can actually see how good they are at communicating their intent. And that, it's the biggest difference that I can find between a developer and an engineer. An engineer is capable of writing good documentation. It's not Shakespeare. I don't expect 20 pages of a functional specification. Usually we do small features, or we try to break down big features on small features. So it's usually a very simple document, but it has to be precise and it has to be clear. So if they show me 20 pages, you cannot focus on what's important. If they show me 1 page that I can immediately understand, they are perfect. So, engineers. I don't want developers, I want engineers. I'm a developer, I don't want me, I want the engineer that I've become over the years. In terms of career, in terms of progression of your career, this is the thing that you have to focus on. That's my strongest opinion yet. You have to decide what you want to be. If you are a developer, you are like, or either a low-code developer, or you're a code developer, or you're a code monkey, or you are just working for near-shore jobs. I don't care. That's, there will be somebody cheaper than you. But if you do the task of becoming an engineer, of worrying about the big picture and all of those things that are important, then you have the opportunity to grow in terms of your career. You can become a solution designer, you can become a system analyst, you can become a system architect. You can evolve, and that will make you a much more valuable asset for any company that hires you. So in terms of your career, for those of you who are developers, think about becoming engineers. It's not the same thing. Thank you. If there are any questions. Fear.
I'm going to be easy on you, so...
Promises, promises.
Yeah, I'm the good cop, he's going to be the bad cop. when you mentioned the Redis clustering, okay, so you had 30 machines and 20 clusters with 3 to 5. So are those interleaved and using multiple cores?
Yeah. So we put multiple Redis servers on Redis instances on the same physical server or VM to make use of all the CPU powers they have. There is one thing that you have to be aware is that there is a fork of Redis that is gaining a lot of interest, let's say, which makes Redis multi-threaded, which is not by default. And they have taken a very interesting approach in which they focus on multi-threading the network and the protocol parsing and protocol generation phase, which are easily multi-threaded. So they didn't do a lot of calculations in multi-threaded way. Redis itself is becoming better at that because they are moving slow operations into extra threads. For example, if you are using delete operation or del command, you shouldn't. There is an unlinked version that actually is, in terms of cost, much, much faster. Because all the memory freeing and all the memory cleanups is done on a separate thread. For us, it was about responsible for a speed up of about 30% when we move from deletes to unlink. Just that change. So in terms of interleaving, yes, we still use it because we are using classical Redis and we are not comfortable enough to move to KDB, which is the threaded version. But it's something that we are considering. My concern with KDB is this. Redis is about 500,000 of lines of code. Okay? The patch for the difference with the KDB is about 150,000 lines of code. So it's a lot of code, right? And so it has to be tested. Good thing, the test suite and the stress test of that is built in Redis passes on the KDB instance, okay? So if you want to simplify your setup and have a single Redis server per instance, which is simpler, KDB is probably the best option at the moment. Hello.
Hi, good afternoon. My question is more related with developer versus engineer, or developer and engineer, and all together, funny, having the great solution to delivery. Just to get your opinion about what, instead of having just the person to solve the problem and move on to the next problem, what you think about having also the persons get all the problems every time and try to improve all the other problems as well. I mean, when what do you think about having someone in your team that have the need to get involved all the time to improve the things that can be improved? I mean, when you try to have someone, when you have someone in your team that wants to get involved with other parts of the other teams and also wants to fix everything.
Yeah.
You know, it's like it's just not going forward to the next problem. It's always to get better what you are doing.
So those people are very rare.
Okay.
So it's like Da Vinci, a modern day Da Vinci, which is a Renaissance man, that you can master multiple trades. You have to be good at hardware system design to understand the trade-offs of speeds of memory, SSDs, across the network. You have to be good at networking to understand the pitfalls of that. You have to be good at distributed systems in general. Okay? So you have to have a large pool of knowledge. I can count in a couple of hands the people that I know in Portugal like that. Okay? So it's there was in the last few years in terms of college education, a very focus on specialization. Some of the courses that existed 10, 20 years ago that focus on learning everything that was to learn, the basics of everything, and then figuring out from there, are mostly becoming specialized, just churning out developers as fast as they can. So having those people is a godsend. If you can find them, keep them, and nurture them, and make them very, very happy, okay? Like crazy happy. The thing is that they are not very common. And when you find one, they are a pleasure to work because they can relate, they can see what an engineer can see and much, much further than that. It's like a system architecture done right. They have a notion, and if you find a good one, they can actually translate between business needs to technical systems, how everything fits together, and creates much better solutions. But it's not common. So you cannot have one of those per team. You usually put them on a special system architecture box on your company, and they are usually have like 1% of the company size, if you are lucky, and they are usually overworked. They do have a lot of fun, for sure, but they are rare. So it's not feasible to base your strategy on having multiple of those. Okay? I wish. I can say that I have 4, 5, 6, and I consider myself a very lucky person. I know them for 20 years, that helps. So there was like a golden age of IT in terms of internet, the boom during the late 90s and the early 2000s. Some people that survived that area become very good system designers, system architects. Those are very good people to hire. Anybody else?
Any more questions?
Thank you.
Thank you, Pedro.